Hello everyone, my name is Hughes Perreault. I'm a PhD student at Polytechnique Montreal, and I'm going to present my paper, SpotNet, Self-Attention Multitask Network for Object Detection. This paper was written by myself, my PhD supervisor, Guillaume-Alexandre Bilodeau, PhD co-supervisor, Nicolas Saunier, and a research collaborator at Genetech, Maguelone Héritier. It is clear that there is an increasing interest in automatic road user detection, either for intelligent transportation systems, advanced driving assistance systems, traffic surveillance, etc. In this paper, we were inspired by the human visual attention, where we kind of automatically know where to look for certain kind of objects. So we wanted to train a network to produce such attention maps. Given video sequences with only bounding box ground truth, we generate semi-supervised foreground-background annotations that can be used to train a segmentation module. The segmentation map thus produced is used inside the network as a self-attention mechanism to improve the object detection task. In this figure, we can visualize an attention map produced by your model on top of its corresponding image. The pixel clarity here corresponds to the confidence that the area is of interest. In order to train our visual attention, we need to produce segmentation ground truth for non-annotated datasets. We produce such ground truth with a background subtraction method for the fixed camera setting videos and with an optical flow method for the moving camera setting videos. We then intersect each imperfect segmentation mask with ground truth bounding boxes in order to remove as many false positives as we can. We use CenterNet as an object detection baseline upon which to build our model. CenterNet detects objects by detecting their center key point. It first processes an image through a backbone neural network. Then, using tree heads, it produces an object center heat map, a width and height for each point, and an offset for each point. In our work, the stacked hourglass network is used as backbone, but other networks can be used. We improve upon the CenterNet model by implementing an internal attention mechanism and train it using multitask learning. We add a fourth head to the model, a foreground-background segmentation head, and train it using our semi-supervised ground truth. The loss used here is a binary cross-entropy. The attention process works by multiplying each tunnel of the feature maps used by the other tree branches by our attention map. Here is a complete overview of SpotNet. The input image first passes through a double stacked hourglass network. Then the segmentation head, which is composed of 3 blocks of 2 3x3 convolutions followed by upsampling each, then produces an attention map. This attention map is used to multiply the final feature map produced by the backbone. And this multiplied feature map is used by the 3 other heads to produce a center key point heat map and a size and coordinate offset for each point. The attention map is also produced in binary form for segmentation purposes. We trained and evaluated on 2 traffic surveillance datasets, UA-DETRAC, which has a fixed camera setting, and UAVDT, which has a moving camera setting. On UA-DETRAC, you can see that not only do we beat the baseline by a pretty significant margin, we also achieve the all-time best performance on this benchmark. This is especially true for the hard examples. On UAVDT, we also beat the baseline by a decent margin, as well as beating all previous methods on this dataset. Even though it is not our main goal, we evaluated the segmentation capabilities of our model on the change-detection.net dataset, which is a background subtraction dataset, and found out that we can outperform some classical methods, but not the state-of-the-art. Here are some examples of foreground-background segmentation maps obtained by our model and some other methods. You can see that ours are a little bit squared due to the intersection with bounding boxes. To make sure that every part of our model is essential, we performed an ablation study. And even though the best result is obtained with the attention mechanism plus the multitask learning, what's interesting to note is that multitask learning alone can be beneficial to a network due to the features being more refined. Our model needs at least semi-supervised annotations in order to be trained properly. However, we believe that in most real-world applications, sequences are available and we can thus run background subtraction or optical flow to generate them. In conclusion, we presented a novel multitask detection model equipped with a self-attention process. We trained it with semi-supervised annotations and a multitask class. We show that these improvements allow us to reach state-of-the-art performance on 2 traffic scene datasets with different settings. We argue that not only does this improve accuracy by a large margin, it also provides instant segmentations of the road users almost at no cost. Here are our references, and thank you for listening.